I'm going to show you two different approaches to balancing chemical equations. Hopefully at least one of them will click for you. I'm going to talk about who has to do it, and I'm going to talk about why. And I think I'm going to start off with the why. Why do you have to balance chemical equations? Well, the answer is it's the law. Which law? It's the law of conservation of matter, or you could say law of conservation of mass. What does this law say? It says that in chemical changes, atoms are not created or destroyed. So when a chemical change happens, you cannot make atoms and you can't destroy atoms. So if we look at this equation right here, something should look kind of wrong with it. It should look like you've destroyed an oxygen atom because you got 2 on this side and only 1 on that side. We don't bother writing that little one subscript, that's just implied, but it kind of looks like we've destroyed an oxygen atom. So I'm going to balance this equation. And one of the two ways that I want to show you how to balance the equation is by using a drawing. So here we go. Let's see what these things look like. Hydrogen looks like this. It's a little diatomic molecule, a pair of H atoms. Oxygen looks very similar. And then water looks like this. You've got 2 hydrogens and an oxygen. So this drawing shows us that it looks like we have destroyed an oxygen atom because we got 2 there and we've only got 1 there. So what do we do? How do we fix that? Well, since we can't create or destroy atoms, we must have had different numbers of these things when we got started, and that must have produced some different number when we finished. So what were those numbers? Well, what we're going to do is we're going to play around with the coefficients. That's numbers that can go here in front of these particles. Because you can't just stick in a little 2 here because that's a different chemical. That's hydrogen peroxide. So you can't just get in there and mess with your subscripts. You're only allowed to put numbers in front of these particles. So sometimes people will draw boxes around these so that way they'll remember, oh yeah, I can't get in here and mess with that. So anyway, what do? I'm going to draw, since I've got 2 oxygens on this side and only 1 on this side, what I'm going to do is I'm going to draw another water particle on this side. So here is my other water particle. Well, the good news is I have solved my oxygen problem. Now I've got 2 on each side. The bad news is that I have created a hydrogen problem. I've got 2 on this side and I've got 4 on that side. So I must not have started with just 2 of these. I must have actually started with 4 of these hydrogen atoms, or in other words, 2 molecules. So if I have 2 of these, I'm going to put a coefficient there, and 1 of these, I'm going to put a 1 here. Usually we don't write that, so I guess maybe I'll skip that. And 2 of these. Now it's balanced. So now we're all set. Because 2 times 2 is 4. We've got 4 hydrogen atoms. 1 times 2 is 2. We've got 2 oxygen atoms on this side, so we've got 4 and 2. And then over on this side, we've got 2 times 2. We've got 4 hydrogens, just like we had over here. And 2 times 1, so we've got 2 oxygen atoms. So this is a balanced equation. Alright, so that's the drawing method. The other way I want to show you, because this actually, look how sloppy I've gotten here. Anyway, the other way I want to show you is to take a tally, to draw it with a, without actually not draw it, to count them up. So let's do this. Here's an equation. This is for the production of ammonia. And we've got nitrogen and hydrogen on both sides, so I'm going to count things up. On the left side, I've got 2 nitrogens and 2 hydrogens, and on the right side, I've got 1 nitrogen and 3 hydrogens. So I am allowed to put coefficients in front of these particles. I can put a number there, there, or there. So let's see here. 2 and 3. What's the smallest number 2 and 3 both go into? Because I'm not allowed to mess around with these formulas. 2 and 3 both go into 6. So how can I turn this 3 into a 6? I can multiply 3 by 2. So if I put a 2 here, that's going to change both my hydrogen number and my nitrogen number. 2 times 1 is 2 for my nitrogen. 2 times 3 is 6 for my hydrogen. So now my numbers are looking a little better on the bottom here. Now I've got 2 and 2 and 2 and 6. So now I would like to fix my hydrogen number. I'd like this to become a 6. Well, how do you turn a 2 into a 6? You multiply it by 3. So this is called the tallying method. You just count things up and then mess with the coefficients until things match. So since we didn't put a number in front of the nitrogen, you could say there's a 1 there. So this is a 1 to 3 to 2 ratio equation. And the first one we did is a 2 to 1 to 2 ratio equation. So that is how you balance equations. Okay, now to finish this video up, who has to do this? Well, let's say you had a factory where you made water, and you were going to order your hydrogen and your oxygen to make your water. Well, you would need to order more hydrogen than you would think. So if you didn't know how to balance an equation, then you would order, the wrong amounts, and you'd go out of business. Oh, okay, so a water factory isn't very realistic, but there are people who make ammonia. And so if you owned an ammonia factory, you would have to order nitrogen and hydrogen. And if you ordered these in equal amounts, you'd run out of hydrogen because you need 3 times as much. So basically, anybody who produces something, if you make something, then you need to have this kind of a reasoning skill. So balancing chemical equations actually gives you skills that lots of people out there use.